balance at expiration. Press 2. To change your mobile number, press 3. To change your equipment or SIM card, press 4. To change your rate plan, press 5. To speak to a customer care professional, press 6. To speak with a please hold. We are now connecting you to our customer care agent. We're sorry, but our customer service department is currently closed. Please call back during our normal business hours. Introducing new seeker with essential oils.
Okay, so welcome back to the classroom. How's everybody doing so far?
Okay. Good morning.
Good morning. And today we're gonna be working on chapter 8, part 2. And I believe that I post a file. Let me just double check that real quick for this reason. And let me share the screen. So anyway, this is what we're going to look at. I changed the information into joining content. It's basically the same thing. And all we need to do is, again, that we're gonna have a same folder, 6, 7, and 8. There will be video included on each chapter. And since I haven't really had time to do chapter 6, but I would definitely gonna do so very soon. How we're gonna do the binomial, how we're gonna do the factorial things, and chapter 7. That when you click on the folder, there are 3 part of it, and there are also practice questions and 2 videos attached to it. And chapter 8, again, there will be part 1, part 2. And since chapter 8 is basically the chapter that right after we finish it, we're going to have the second exam. So I do not really give out any practice questions. I literally just work on the review, exam 2 review question. And literally, we can check the lecture videos along the way. And the part 2 was posted. And so today we're gonna be working on this part. So again, that for all of you concerning the about the chapters or about the homework problems, just don't worry about that, because I'm gonna give you guys a decent amount of time to finish all the classwork. So let's say you just need to submit them before the second exam. So making sure that we submit all the classwork 15, 16, whatever that we left over from 13, 14, 15, whatever it is. So before the second exam. So if people submit it late, I completely understand it. And if you have any trouble, if you know somebody in our class has any internet connection issue or any technical issue, so let me know. I'm going to help them out for the class. Okay, so now we're gonna go to so this is a chapter 8, part 2, and so we're gonna go to exam 2 review questions. Exam 2 review questions. So this is what we have to literally practice as many as you can. So if you can do all of them, you definitely get 100 on the second exam. So I'm gonna change the format of the questions, and I will let you know how we proceed to exam 2. It's literally 2 weeks from today. Okay, so make sure that we're gonna take. Let me just check the exam. So today we're gonna finish part 2, and Thursday we finish part 3, and after that we're gonna have 2 review for 21st and 23rd, and then we're gonna have the exam on April 28th, and we come back to it to do chapter 9 on April 30 and May 5th, and after that we're gonna have around two final exam review on 7 and 12. That's pretty much the thing that we'll be doing. So after the 12, we no longer have any classes. We just wait for the final exam. So if people really concerned about the final exam review, don't panic, because I actually have a lot of files that can help us practice as many questions that we can. So if you really worry about the final exam and when we're gonna be taking a final exam, I don't even know. Usually, the math department going to tell me when we're gonna take the final exam. But since this semester that we're doing online, so we do not have that uh, priority. But I will let you know how we're gonna make up the final exam for us. So for the time being that we're gonna cover chapter 8, part 2. So when we learn from chapter 8, so let me just draw a picture real quick. And this is really important, and this is how we're gonna distinguish between these two chapters. So remember, there will be three questions, usually three questions on chapter 8. So each question going to be one single part. So let's say part 1 is one question, part 2 is not a question, and part 3 will be not a question for that. So, so what we need to be doing is that um, we need to learn how whenever we have a sigma. So the sigma is something that we have right here. So when you see the sigma, and it's literally the thing that we can check them out. So this is when the sigma is known, and this is really important. And so, so when the sigma is known, meaning what? Meaning that when you catch these letters on the questions, for example, when we catch this letter. So let's say we take a look at chapter 8. So how do you know it is in chapter 8? So whenever the question gives us confidence interval, right? And then we have to do chapter 8. So whenever you will see that little choppy O for that part, but not chapter 7, right? So choppy O that with the confidence interval. Okay, so let me just figure it out. 47 is not, is chapter 7. 49 is not. 50 is not. 51 is not. 52 is not. So we finish. So let's say you see the keyword confidence interval, right? And so it's given on the questions. On the question. And we also have and what else? We also have confidence interval. I would say CI. I usually don't write that much on it. So we call it confidence interval. And whenever we see those things, then we definitely going to use the z-test, right? We're going to find the error bell. So this is all we need to do. Whenever the question gives us the sigma, which is called population standard deviations, confidence interval, then we need to use z. Okay, when computing. So the error bell that we're going to be doing will be the e equal to z times the standard deviations over radical n. So this is very important. Okay, but back in the day, where the student, actually not the students, so where people use this error bell, this estimation widely, but there was a student back in the 1918, I believe, and I mean his statistics doesn't really have a very long history. It has around 165 years, a certain time like that. So before that, so people found out that using the z is actually um, not really efficient, especially when we do not know how big of the population is, and how can we compute a sample standard deviation if we don't know the mean, right? So in fact, this test, we call it the t-test. The student that actually developed the t-test, so the t-test was published in 1918 by an Englishman back in the day, and he actually came up with that distribution. So the distribution that we going to do, that we call the t distribution. So the t distribution is literally, we call it a student t distribution because this was developed by a student. If you ask me why it was developed by a student, well, because it's basically the student who developed it. And he's not an academic professor, it's just the student itself. And he or she actually, came up with an idea of what that distribution looks like. So this is how it looks like. Okay, so when we look at the t distribution that you can see, why there are so many curves in one single picture. So the probability density function is basically indicating what the curve looks like before we can utilize them. So what's going on for this part is when we look at the curve, right? So it's different, correct? It depends on this letter we call V. The letter V is basically what we call the degree of freedom. Okay, so let me just rewrite them. So a student, an Englishman, um, developed that a long time ago in 1918. He was one of the story that I know along with the Chebyshev theorem. So developing a student t-test. So again that so what's so special about this t-test? So let me just write them down real quick. So it's literally the normal distribution. It's basically pretty similar to the z-test, except for the fact that we need to count the sample size. So this is normal. Okay, it's pretty much similar to the z, but what makes the t-test different is when we are looking at the degree of freedom. Okay, so some people ask me, what is the degree of freedom? So the degree of freedom is based upon how many samples do we take, right? So in other words, so the degree of freedom will be equal to, we call df. So we have degree of freedom, and so why people use df, just want to making sure that it's easier to write. So the degree of freedom will be df equal to n minus 1. So some of you might be asking why n minus 1. This is pretty much the same things as you asking me, why do we have to divide it by n minus 1 when we compute the sample standard deviation? Why don't we divide it by n, but why always be the n minus 1? So one picture of it is because this is a sufficient statistic that people prove them, not in the very basic elementary statistic that I can't show you what it is. All right, so n minus 1, we're trying to make the sample standard deviation similar to the population standard deviation. When we deal with the sample size, it's the sample standard deviation we call S, right? So what's going on for that is when we're going to use this t distribution, whenever you see this letter, okay, this letter S is given. So this is really important because on the exam, if you mess that up, you're gonna get the wrong thing. So S is given, okay? So you don't see the little sigma, a little choppy O that we have right there. So the sigma meaning that the population standard deviation is known. So let me just use the picture to analyze that. Uh, so this is a population, right? We call N. We call big N. Okay, so we don't know how big of the sample size. And of course, we do not know what it is, right? If we know this guy, that would be this, that would be the Z. It's simple. But since the question is that we don't know how big of the population size will be. So if we try to estimate this, how can you do that without this? That's impossible, right? We don't really know how big of the sample. So how is that possible that we can use a population standard deviation? So there's no way that we can do so. So in other words, we're going to generate information using a very typical sample size that we call N. So as a matter of fact, on the exam that we never write down the big M, the capital M. We only be given by a small m. So coming from the small n that we can analyze that small sample, this is what we have to be doing in statistics, that we develop that we can compute the sample mean and sample standard deviation, okay? So this is why the student was really, really brilliant when he developed this test. Since that we don't know what it is, but we have this guy, we have the S. So how can we utilize the sample information to estimate the population mean? So that basically the thing that we'll be doing. So in other words, let me just help you analyze how it looks like when we look at the student. So basically, the student t-test is basically a normal curve, but the curve vary depends on how large of the sample size n. So let me just give you a very, very detail for that information. When we look at table number 4, let me just go to format package. So this is all we need to, this is what we need to do when you look at the table number 4. This is the table that we have to use. So table 4 is literally telling us this is for the critical value of the student t distribution. So we need to use this table for chapter 8, part 2. It's critically the thing that we have to do. So if you ask me how people came up with this number, so again, that they use the probability density function for the t-test, okay? Depending on, so let's say we have degree of freedom equal to 1, so that'll be 2 samples, so they have a different test, the different function. Degree of freedom equal to 2, we have 3 samples, right? So they have different function for that, and then we based upon the function, we compute all of these score. So this is pretty much a thing that that they have to do in statistics. But we're not gonna be knowing all of this. We just basically want to use the table and understand what it is. Okay, so let's say we look at the 3 samples. So let's say I only give you 3 samples, n equal to 3, the small n. So coming from a big population, I take out 3 samples, and then we can literally check that the degree of freedom will be n minus 1, n equal to 2 at 99% confidence. That's 99% confidence. So how can we check the confidence interval on this chart? So this is what we call the confidence, okay? So the confidence interval, basically we call C. Why we use C as a confidence level, I don't know, because it's easy to use the letter C, okay? And since the chart doesn't have enough space to write down like confidence interval, so they just use a C to represent this one, okay? And they use the DF to represent this this column. One single column will be called the DF, so this one will be the C. So in order to make it simple, let me just check them. So 99% basically this guy, okay? Remember, the exam question will never gives us 99.9%. This one is, we don't want to be like 99.9% sure of what's going on. We just only need to have like 99%, meaning that we have 1% chance that we can have an error for that. So this 99% that we convert to 0.99. And when we look at the chart, what's going on? So when we look at the chart of degree of freedom equal to, that's 99%, you can see that the T score, the T will be 9.925, okay? So what's going on for that part? So the error bow is no longer equal to the Z times sigma over radical N. The error bow is basically equal to the T, right? We no longer use the Z test. We basically do the T test and time S. So remember that we don't know this guy. We don't know the population standard deviation. If we know this guy, everything everything should be done very, very easy. But the fact is, we don't know how big of the population. How can I compute this one? So statistician, they argue that I can use the past data set, all right? So assuming that I know the last year's statistic, whatever it is, and I want to predict this year's statistic, okay? So they basically take the past data set when they um, treat this, okay? But this is not working. In other words, that we have to replace this guy by S, okay? So instead of we using the choppy O for that part, and then we basically do the S over radical N, okay? So we basically have to change two things. Instead of using population standard deviation, that we change to the sample standard deviation. And instead of we using the Z, we have to change to the T. Okay, so the error bound basically depends on how big of the t-score, how big of a sample standard deviation, or how big of the samples that we collect them. Okay, so again, the error bar is where we're making error. This is the chains. So what are the chains that we can make an error bar for that part? So, and when we look at the 99% at 2 degrees of freedom, that you can see that it's really big. So in other words, when you see that, so at 2 degrees of freedom, that we can check that this is 9.925, right? At 1 degree of freedom, that even huge, meaning that the error bar is big, the estimation is really bad. So in order to reduce the estimation errors, of course, the better way that we can do so, we're going to increase the sample. And because the more information that we know, the better decision that we make, the better estimation that we make as well. So when I increase the error, the sample size to 6, so let's say I collect 6 people or 6 sample, and meaning that I have to look at the degree of freedom equal to 5, so I can check them, and the t-score basically getting smaller and smaller for that. So at 99% confidence interval, so we look at the degree of freedom equal to 5 and 0.99, so we can check that it's reduced from 9.925 to 4.032. So we can see that the t-score basically reducing, because the t-score basically representing the confidence interval for that part. So let's say representing this part. So whenever we have like a big sample, so the curve becomes something like that. Okay, so meaning that there will be more data set that focus on the central instead of focus on the tail. In other words, now let me just increase to a certain point. Let's say I increase to the degree of freedom equal to 20, and you can see that at 99% confidence interval is basically 2.845, and it's basically getting smaller. And now when I go to infinity, and I'm not sure if it asks you guys to change that to the Z, what happening for that is when I increase the sample that we collect, okay? So instead of whether we have like a like 2 sample or 3 sample, now we increase to like 1,000 or infinity, right? So meaning that you want to collect so many sample instead of 1 sample, that we collect to like 10,000 sample, whatever it is. So as 99% confidence interval is basically converges to 2.576. What's going on for that part? So when you look at the z-score, and I look at 99%, and it's also equal to 2.58, which is, no, 2.58 is how they round them up. And if I look at the table 4, it's basically the same values, okay? So similarly, when I look at 95%, of the z-score, I got 1.96. This is what we learned from the last class. But when I look at 95% of the t at degree of freedom equal to 19, that we have, no, they have different score of 2.093, 2.086, whatever it is. Keep going, but you can literally check that it's going to be the same values as we increase the number of n. So in this case, when n becomes really big, meaning that you couldn't, we collect a lot of sample, and so it's become 1.96 as well. So I can also check that as 90% confidence interval of the z-score is 1.645. similarly, that we can get the z-score of 90 of the t-score of 95%. But when we have a big sample, so we can check that it's also 1.96. So this infinity represents the z-score. So what's going on for that is the fact that as sample size becomes really large, the t converges to the z. Okay, so let me just point it out. This is more like theoretical questions. As sample size becomes really big, okay, as n become infinity, I would say becomes really big, right? Big number. Okay, so what's going on for that is that we have a sample standard deviation, basically almost similar to the population standard deviation. Okay, similar to that one. And we also have the t convert to the z. This is a key point when we're doing the statistic, meaning that when this gets really big, okay, the error bar should be almost equal to 0. Anyhow, and so now what we have to do, we're going to do the same thing for that part, that we're going to do after we compute the error bar. We just literally have to do x bar minus the error, and x bar we add the error. That's pretty much it. Okay, and again, that the error bar based upon what? Based upon how many sample that we have, right? And also based upon the sample standard deviation. I mean, the standard deviation actually the key point, because when you have like a small standard deviation, meaning that our data set is more predictable compared to the big standard deviation. But those two numbers cannot be changed. So there will be a chapter we call Chapter 8, Part 3. This is where we're going to balance out between the n and the error bar. Okay, so some people, they want to have like a really controllable error, and so they might have to have a considerable sample size to satisfy the need. And so this is how we want to play around with statistic. I don't have time to collect like 10,000 data set. I don't have time to collect maybe 2,000 data set. I only have time to collect 20 data sets. So this is how we're going to balance out between the error and the sample size. So this is what we will be learning on Chapter 8, Part 3. But now we're going to be doing Chapter 8, Part 2, where we're going to utilize the t-test, the t-distribution, to evaluate the error and the confidence interval for the population mean. So so that's pretty much the thing that we have to deal with. Okay, and so this one again that we have to do table number 4, and this is the only thing that we need to worry about. And but the z that we use table 3, right, 3b. In fact, this is what we got to be careful. So table 3b, and that's pretty much a thing that we have to do. Okay, so they're basically 2 steps ahead of us. So when we're gonna use the t and when we're gonna use the z, again, that I pointed out very quickly. When a question gives us this guy, then we definitely have to do this. When a question gives us this part, then we definitely have to do that. So let's just practice a very small question and see how it worked out. So whenever like I read that, the questions gives 90% confidence interval, right? So we're definitely not going to do, and then also saw a little choppy O, we're definitely not going to be the T. So this guy, I have to do the Z, okay? But whenever I see the S, right? So the sample standard deviation S, I see a little S, like a snack, I would say, my students usually call it. So whenever I see a little S right there, and then we also have 99% confidence interval. So this is where we need to compute the error bar based upon that. So let's try and just check this question out real quick. And let me just copy and paste. I believe I did this questions, but I'm just not so sure. Okay, so let me just copy and paste first and check them. So now we have this part. Okay, so now we highlight them. We highlight a few keywords for this part. Okay, so the thing that we need to highlight will be the mean, right? X bar, so this is the things, and also followed by the random sample. So this is the N. Okay, so when a question gives us random sample, and also the whole number, but there are two whole number right there. But this one definitely not going to be the N because this is it has the X bar right there, and we also have the S. So the S equal to 10. It's very important. The question gives us the S. Okay, so whenever you see a letter S right there, okay, because the sample stand deviations, so then we have to do the T. Okay, so we're going to put this little finger right, we're going to write them down, we're going to take note of that, and then we can see that this is what we have to do, the D, E. And then we also highlight this is the confidence interval. And remember that we only do the confidence interval when the question asks us to do so. Okay, so what is the 99% confidence interval for the population mean test for all high schools, right? So the first step, we write down information. I feel like it's really important that we can write them down so that we don't lose any information that we have. So the first step, I write down the X bar equal to 85, and the second step, I write down the N. So the N that the question gives us 36 people, 36 high school girl. But this question that it took almost like maybe 20 years ago, where people only test like 85 text messages per day. In fact, I test more than that. Of course, much more than that. People test more than maybe 10,000 messages per day. I don't know. There's a lot of things going on. And then we have the sample stand deviations. So that would be equal to 10. And finally, that we're going to rewrite the confidence interval will be 99%. Okay, so whenever the question gives us 99%, so we need to convert to 0.99. Okay, very important, because when we read the table number 4, the T, they only gives us the decimal number, so we need to convert to 0.99, but definitely not going to be the last column. So we need to convert to 0.99. If the question gives us 95%, then we have to convert to 0.95. If the question 90%, then we have to convert to 0.9. So this is really important that we should know how to convert to and do the math correspondingly. So whenever the question gives us the T, it will be a little more complicated. So what we have to be doing, pretty much the first step that we need to do was to compute the error value. So the error would be T times S over radical N, right? So what is the T? So the T is, so the first step that we need to look for the degree of freedom. So the degree of freedom would be called df. So what is the degree of freedom? The degree of freedom would be n minus 1. So let me just write them there. So the degree of freedom, so that would be n minus 1. So we have 36 member, we minus 1, I get 35. Okay, so this is what we need to do for this part of the questions. So on the other hand, and after we get the degree of freedom of 35, then we have to go to the chart, okay? You go to the chart, table number 4, we go to the degree of freedom equal to 35 on this part, okay? So I might make it a little smaller. Okay, and now I go to 35, degree of freedom, go all the way down, and go to 0.99. So the answers for the T score will be 2.724. Let me just repeat that again. So since the question gives us 36 sample, right? So we're gonna go to the degree of freedom equal to 35 and 0.99 confidence interval. So I got the answer, which is 2.724. So so this is how we're gonna fight down on the chart. Okay, so first we need to put them down. This is what we're going to use, table number 4. Okay, the T. So again, when we're going to use the T, because the question gives us the S, okay, the sample stand deviations. So what we have to do for the first step is that we're going to make the chart, right? We're going to go to the chart of table number 4, I would say. So now remember this is the DF, right? The column will be the degree of freedom, and the row will be the confidence interval. So you go to we go to 0.99, 0, okay? We're not gonna use 0.99. We only use 0.990. So then we're gonna go to degree of freedom equal 35. And then we take the intersection between these two. I believe that we just did 35 and 0.89, so I got the answer, which is 2.724. And so we're gonna put them down, 2.724. Okay, so this is how we're gonna read the chart for table number 4. This is what's happening. This is what makes the question different. So that'll be 2.724, and then we finish that part. So meaning that we're going to take 2.724. We multiply by the sample standard deviation. What is the sample standard deviation that we just did, that we just saw right here? So we multiply by 10. And then we divide it by radical n. So remember, when we do the n part, what is the n? How many samples? So n is 36. Some people divide it by 35. This is wrong. We only use 35 when you read the chart, right? But we're not going to plug in 35 into the n. The n is actually 36. We have 36 people. We have 36 high school girls, right? So we're going to divide it by radical 36. Okay, as simple as that. Pretty much the same thing, except when you look at the t-score that we have to go to, degree of freedom 35, and then confidence interval, which is 0.99. So we do the same thing that we learned. And let me just use the calculator real quick for that part. So again, that if you don't have a calculator, make sure that you download one. This one is free, and it doesn't really cost us anything, and make sure that download it on a computer in case that your calculators run out of batteries. So I have 2 right here. I mean, people can use like 10 calculators at the same time, but so now we look at the questions right there. So we're gonna take 2.724 times 10 over radical 36. So I take 2.724 multiplied by 10 and divided by radical 36. Okay, and then, so this is how we're gonna do so, right? So I'm gonna take 2.724 multiplied by 10, and then we just divide it by, take the second, and take the square root, and then you put that 36, and you don't even need to close parentheses, but just want to modify them, and we're gonna get the answer, which is 4.54. Okay, 4.54 for that part. After we get 4.54, and all we need to do, just build of the range for the population mean for this part. So the range for that would be x bar minus the error, and we also have x bar at the error bow. So this is what we usually have to do. So this is what we call the range. When we read the textbook or the chapter, so we can literally check on the chapter summary, and so the formula that we can see, this is the formula that we gotta use. Okay, so the error bar will be the t times s over radical n, with the degree of freedom n minus 1. And after that, we're gonna take the x bar minus the error, and x bar you add the error. So this is how we're gonna look for the mean. So the mean have to be bounded between these two numbers. So in other words, what we have to do, I'm going to be doing, so the x bar that we have in this case is 85, correct? And then subtract the error bar is 4.54. Similarly, we do the same thing for the right side. We're gonna take 85 at 4.54, and we get it for this part. So, so that's pretty much it. And so we just do the math accordingly. and let me just do it right here. And look, make it bounce out a little bit. Okay, so now it look better. So so we're gonna take 85 minus 4.54, and we got the answers, which is 80.46. So that's pretty much a thing. And then we're gonna take 85 plus 4.54, which is the error bar that we have. So the answers for that is 89.54. And so this is how we're going to call the bear for this for the sample mean, and then we'll finish it. So this is literally the thing that we need to do on the exam. So again, the first step that we're going to check if the questions gives us the S, or if the questions give us the sigma, which is the choppy O. So if the questions gives us the S, then we're going to use table number 4 to look for the t-score. You definitely have to do the t. And so we're going to take the error will be the t times S over radical n by using table number 4 that we can figure out the degree of freedom equal to 35 and a confidence interval, which is 99%. Okay. And then we look for the chart, we get 2.724, and then we proceed to net accordingly to what we learned from chapter 8, part 1. So we go to 2.724 times 10 over radical 36. So we got the answers, which is 4.54. And after that, we just need to take the x bar minus the error and x bar add the error. So that's pretty much the thing that we need to do. So what does it mean for that? So we are 99% confidence, right, to say that, to conclude that the population mean, or on average, or high school girl on average text between 80 to 89 message, right, to 90 messages per day, right? So this is what we need to conclude. That's pretty much the question that we worked through, and this is all we need to do. So chapter 8 was not really complicated, except for the fact that we need to pay attention to whether or not the question gives us the S or the question gives us the sigma. So so that's pretty much your thing. So let's practice a little more question and see how we're going to proceed to that. So let me pick a question. I cannot do that, right? So this is the sigma, so we cannot do the T. Let me pick the question that I can do the T. I would say question number 29, right? So the reason why I'm going to pick these questions because it gives us the S. Okay, so let me just finish posting that. And then we're going to proceed that questions. Okay, so again, let me just repeat that again. The reason why I can do so, because the questions gives us the S right here. Okay, so when the question gives us the S, definitely that we're going to do the T. There's no doubt about it, right? Always be the T. And also the question gives us a small sample size, a random sample. So this would be the N, apparently. So this is the N. Okay, and then after that, we're gonna look at the X bar. The question has to gives us the X bar. If the question doesn't give us the X bar, you gotta be careful for that. This is part 3. And then the question also gives us the confidence interval that we can literally check that. And so again, whenever the question gives a confidence interval, definitely that we have to do for the error bar out. So we're gonna write down the informations, the X bar equal to 5.03. Okay, and then we also have the N equal to 12. And we also have the S equal to 3.38. Okay, so if you ask me, do we have to write down the information? The answer is you don't have to, but just in case that we forgot anything. And so it's better to put it down and see what's going on. So, and then the confidence interval would be 0.95. So we need to convert to the decimal number is 0.95. So again, whenever we have to do the t, then we need to compute the degree of freedom. So the degree of freedom that we have is n minus 1. So we have 12. So 12 minus 1 will be 11. Right? Apparently this is equal to 11. And now we're going to do the error bound. So the errors bound that we have would be equal to the t times s over its radical n. Okay, so after we do so, we finish it, we're going to take the x bar minus the error, and x bar, we add the error bound. That's pretty much. So how many steps do we have to do? 2. The first, we do the error, and after that, we take the x bar, add the error, x bar, we subtract the error. That's pretty much it. I have a student, he actually doesn't want to do it that way. You just do the x bar plus and minus error, and then just do pretty much the same thing, just a different way that we write them. And and now we're gonna do table number 4, because the t, we have to do table 4. And so after we go to table 4, we're going to look at the chart, right? The chart going to gives us so let me just erase that. So the degree of freedom, so we're going to go to what is the degree of freedom that we have for table 4 would be 11, because we have 12, right? We have 12 samples, so we have to go to the degree of freedom equal to 11. And so the confidence interval that we have is 0.95. Okay, 0.95. And then when we go to the chart, and we can check that the answers was 0.95 and 11 and 0.95. Now I can make it bigger. So 11 and 0.95, so 0.95 and 11. So we take the intersection for that. I got the answer, which is 2.201. So I'm going to take 2.201. So I just put them there first. Right, so this is all we need to do. So let me just erase that real quick in case that we do not do so. So that'll be 2.201. And then we multiply by the sample standard deviation. So the sample standard deviation that we just have right there is 3.48. Okay. And then we divide it by radical 12 is not 11. Remember that when we divide them, when we look at the degree of freedom, so we have to go to 11, but when you compute the error, we still have to divide by 12, because n is 12 is not 11. So we divide it by radical 12s, and then you can just check them on the calculator. I'm going to take 2.201 times 3.48, and we divide it by radical 12, and the answer for that is 2.21. Okay, so 2.21, because radical 12 is actually close to 3.48, so it doesn't really change that number that much. So 2.21, let me just rewrite them. So this is 2.21 and make it a little bigger for that part. Oops. Oops. It doesn't look like that. Let me just erase it. Okay. And 2.2. So finally, that we just have to do X bar, which is 5.03, right? So the mean that we need to compute for the range is 5. We take 5.03. So let me just do it on the letter. So I'm not really good at drawing. So we're gonna take 5.03 minus 2.21, and on the right side we take 5.03 plus 2.21. That's pretty much it. This is all we need to do. So finally, so we're going to do the math on the calculator. So 5.03 minus 2.21. The answer that we got is 2.82. And 5.03 plus 2.21. And the answer that we got is 7.24. So finally, that we just rewrite them. So that would be 2.82 and 7.24. So that's pretty much the answers for this. Okay, and so the conclusions would be the thing that we need to put them down. We are 95% confidence. To save it. The absence, right? So the average day of absence for all sickness, for all people, because we represent the entire population. We're not going to just say for 12 people. No, this is for all people. So what's so powerful about statistics is that when we make a conclusion, we make a conclusion on a population, not going to be on the small sample of 12 people that we just did. So we want to make 95% confidence to say that, to conclude that the average day of absence for sickness for all employees is between around 3 and 7, right? Or maybe 2.82 and 7.24. Just want to be exact. So we pretty much finished the question right there. Okay. So so I would say this is the question number 29 on the list. So this is 29. Just want to make sure that we so this is question number 29. Okay. And now we're gonna go to the next questions and check them out real quick. And so let me just try. Yeah, so this question is definitely going to be the key where we're going to do the T, right? So why we have to do the T? Because I saw the question gives us S. So whenever I see the S, then we have to do the T. And all we need to do, again, that we're going to copy and paste questions right there. Okay, we're pretty much doing the same thing. Since we're running out of space a little bit, so I'm going to make it a little bit smaller. I apologize for my spacing. And so now we're going to analyze the questions for that part. The S that we have on these questions is 1.6. Okay, and we also have the N. We can literally check that the N equal to 20. Right, we have 20 covered. And we also have the X bar, that would be 33.7. Pretty much a thing. So let me just go back here and just point it out, 33.7. And we also have like 90% confidence interval right there. So this is all we need to put them down. on the list of the questions. So the thing that we need to do, we're going to write out information. So the X bar is 33.7. And we also have the S equal to 1.6. Okay. So after that, we're going to look for the N equal to 20. And we have a confidence interval. So the confidence interval I call CI is not CIA, just CI itself. So that'll be so 90% is 0.9. So remember, we don't use a lot of confidence interval. We only use 90%, 95%, and 99%. So there's nothing wrong with 80% confidence interval. There's nothing wrong with 70% confidence interval. Just the number is not really credible. It's not really valid when we use a certain small confidence interval. So the best strategy for statistics is basically they try to balance out and use 90%, 95%, and 99%, right? So what the point when I can conclude, I am 1% confident to say that the bow is between, it doesn't make sense. If you only have 1% confidence, you want to get more confidence along the ways, right? So it is a probability perspective, right? You want to be 90%, meaning that we still have 10% change that we can, the mean is not fall within that, okay? But the 90% change that for this question, for example, is we are confident to say this is have to be the mean that bounded between this and that. So again, that we're gonna do the error. So the E will be equal to the T times S over radical N. We just do it over and over again, right? And so the T that we're gonna use, again, that'll be table 4. Again, the T have to be table 4. We can't use different T for that. So table 4. And so all we need to do, oops, okay. So all we need to do, again, that we're gonna go to, we need to compute the degree of freedom. So the degree of freedom would be 19, we take away 1 from 20. So in this case, we can have BF equal to 20 minus 1. That will be equal to 19. So let's just make it a little bigger for that part. So again, we only compute the degree of freedom to go to the chart. So 19 with 90% confidence. So we're gonna go to the chart. We go to 19 degree of freedom and 90% confidence interval. I got the answer, which is 1.729. Okay. Okay. So so after that, we're going to take 1.729. So I'm not going to draw a chart because I don't have enough space for that, but you suppose you know what it is. So
I have a question.
Yeah.
Do you have to do the E equals T, or can I just go straight to the 1.729?
Oh no, I mean you better write down the formulas. Yeah, so the formula is just right there, and you can. I mean, if you don't write the formulas, how do you know? Okay. Yeah, so we need to write them down for that part so that I can check. I can see what it is. So because when you do the exam question, I'm going to check the work most often, right? So we need to know because the question gives us the S. So when the question gives us the S, of course, that we have to do the T. So this is how we're going to write them down. Other than that, I might just, all right, so you don't tell me whether it is a T or Z. So I look at 90%. I might use table number 3B. And I check the answers. I got 1.645. Which is different from the answer that we got. And I might, okay, sort of,
I understand.
Yeah, questioning what we have, what we came up with that number. But anyhow, so put them down to T times S over radical N, but you don't have to show me it is on table 4. I mean, if you show me this one, meaning that we understand what it is and we use the different the table for that, but at least we need to put them down to forms, right? So other than that, And I might assume that we don't know this guy. Well, it's pretty much that it's given on a question, which is 1.6. And so I feel like writing that form is really important. And divided by its radical n in this case. Remember that when you look at the chart, we go to 19, but when we divide them, we have to divide by radical 20 because n is 20, it's not 19. Right? We just go to the chart, we take away 1. So we do the math on the calculator on it. So 1.729 times 1.6. And then after that, we divide it by the square root. So I want to have the square root, I have to take the second, and then x squared, and then 20. I don't even need to close the parentheses. So the answer would be 0.618, or I can round up to 0.62. And so that pretty much a thing that we have for the error bell. So that would be 0.62. Okay, so so let me just make it a little bigger. Okay, so after we compute the error bell, we're pretty much done, and we're going to rewrite the bell for the mean. So the bell for the mean that we call the x bar minus the error, and x bar, you add the error. As simple as we have right there. So of course that we need to put down the forms before I can know what we're trying to do, right? We're gonna take the error, x bar minus the error, and x bar, we add the error bar. So meaning that we're going to take the x, remember that we have to use order value. The question gives us the x bar will be 33.7 that we haven't touched them. So of course that we have to touch it in order to get it done. So we take 33.7 minus the error is 0.62, and then do the same thing on the right. We take 33.7 plus 0.62. And so, and we just do the calculator. So there are actually 3 calculation. I mean, two small competition and 1 big competition when we compute the error. So meaning that we're gonna take 33.7 minus 0.62. I got 33.08 and 33.7 plus 0.62, and we can get the answers, which is 34.32. And so that's pretty much the final answer for that. And the part that we need to compute this, if we don't compute it, you're gonna lose 3 points, 3 or 4 points for that part. So that'll be 33.08, and this one is 34.32. So let me just check. Yeah, so that's pretty much it. So this is all we need to do for the range for the population. And since I'm not going to have enough space to write them down, so I'm going to just put them down. This is the range for the mean, the population mean. So what does that number tell you? So I am 95% confidence the mean of the new model. So this question was pretty old. They're actually the car that they can run more than 40 miles per gallon, but this question was taken pretty much a long time ago. We don't have the hybrid, we don't have electric car, but it's just for the gas, okay? And so I can conclude that there will be 90%, I'm 90% confident to tell you that all the cars, all the new model of a car, basically going to have to run the around 33 miles per gallon up to 34, around more than 34 miles per gallon for that. And so this is all we really care about. Okay, so let me just put in there. I just want to make sure that we understand this is the range. Okay, this is not the value. If you ask me, hey, what is the mean? We don't know. Right? We never know what the true value is. We never know what the mean. How many days people? How many days that people got sick? So I can confidently tell you that that should be around less than 3 days and more than 7 days. And same thing, it should be more than 33 gallons, but less than 35 gallons, right? So this is the information that we can have based upon a small sample. So again, that the conclusion that we make has to be on a population, but the thing that we do, basically we call statistic. So the reason why we call statistic, because we basically do the math on this small sample. So the thing that we've done, basically on the sample size of n equal to 20. Okay, so that's basically the thing that we need to worry about. And so again, when the questions, it's very straightforward. When a question gives us the S, then we definitely have to do the T. When the question gives us um, the the choppy O or the sigma, we call it sigma. Okay, and then um, we have to do the Z. So let's do question number 30, and I want to see how we going to proceed that. Okay, so two different questions again to check if we actually understood what's going on for each part of the questions. Okay, so let's do question number 30 and question number 42. So I want to see the difference between these two type of questions. So we finished question number 29. We also finished question number 27. So let me just put them down. 27. We're done. And again, that all the notes will be posted on Blackboard. We can check the note under the lecture note right there. So I categorize each lecture, and they have a certain note associated with that. And we can check them along the way. So now we're going to go to the news part of the we're going to go to two more questions. So I'm going to go to question number 30 and question number, I just said, I would say 30 and question number 42. Okay, so let's do question number 30 first and see how we're going to proceed that question. Okay, so, all right, so let me just make it a little bigger so they can see them clearly. Okay, so, all right, now we're going to analyze it. So this is question number 30, I believe. Okay, and let me just put it down. Question 30. All right, so what you need to do, we're going to analyze it and check this guy. We have the n equal to 110, right? And we also have the standard deviation, the sigma, and we also have the x bar. And pretty much we have a confidence interval. So whenever you see the choppy O right there, or the standard deviations, then we have to use the Z, okay, the Z. So this guy, we have to use the Z. It's not going to be the S because the question gives us a population standard deviation. Right, so let me just make it a little bit smaller letter so I can see, check them out. Okay, so so the error value we have is E equal to the Z times the sigma over radical n. Remember, I am allowed to write down this question. This is 8.1 because the question gives us that one. Okay, so how can we figure out the Z? So first, I write down the questions. So the X bar is 93.2, right? I mean, you don't really have to write them down. Just the reason why I usually write them down because I do not forget anything on a question. I'm just too lazy to go back to the questions. And so I'm going to take X bar equal to 93.2. And after that, I'm going to write down the n equal to 110. Why do I have to write them down? So that I don't forget it when I plug in the values. I don't forget. I know which value that we have to go through, right? And after that, we're going to write down the sigma equal to 16.9. And we also have a confidence interval. So that would be 99.9%. I'm sorry, 99%. We never see 99.9%, so only 99%. So for this part, we don't have to convert it to 0.99 because you just literally use table number 3B, right? Table number 3B that you can check the 99% is 2.58. Or you can use this guy, 99% for go to infinity. This is also the z-score, 2.576. So if you ask me which number is better, so of course 2.576 is actually a more accurate number. But of course, I don't want to give you guys a lot of headaches. So let's just take 2.58, that's fair enough. So, and then we're going to take 2.58, right? And then we multiply by the standard deviation. Remember, the z-score that we found using table 3B is 2.58 on the list, okay? And then we multiply by the standard deviation is 16.9. And then we divide it by the radical n. So the n that we have is 110, right? So again, whenever the question gives us the z, we do not compute the degree of freedom. We do not care about the degree of freedom, right? So remember, when you read table number 3B, there's no degree of freedom right there. I just go to the confidence interval, which is 99% is 2.5. This is the fixed model. This is the fixed one. It doesn't depend on how many samples do we take, right? So we do not compute the degree of freedom. Some of you see this question on the exam and sort of like, should we compute DF for this type of question? No, we don't compute them. It's easier. We just literally check the CHOPPIO and then just go for the Z. And then you just put them there, 110. And after that, we're going to do the math, the competition for that part. We're going to take 2.58 times 16.9 and divided by the square root of 110. So, and the answer for that is 4.16. So that would be the thing. So if you keep me 4.15, that's fair enough. I don't take away point. So that would be 4.16 or 4.15, doesn't matter. So 4.16. And you don't necessarily have to route up and route down. I just want to make this class make it a little simple for that. But usually that you have to route up because the third decimal number is 7. But if you keep me 4.15, give you full credit for that. So now we're gonna do for x bar minus the e and x bar at the error. So this is the thing. So now we're going to do, we did you take into account the x bar that we have is 93.2, right? And we're gonna do so, 93.2 minus the error value we just computed, 4.16, and then we take 93.2 plus 4.16, as simple as that. And that's pretty much a thing that we need to do. And we do it in a calculator, 93.2 minus 4.16. So the answer is 89.04, and 93.2 plus 4.16. We have 97.36. Okay, so this will be the answer for that. And so we're gonna be 89.04, and on the right that we have 97.36, right? And that's pretty much a thing that we need to do. And we can conclude that we are 90% confidence, 99% confidence, to say that, to conclude that the mean times for the computer repair, is between 89.04 and 97.076 minutes. I mean, you don't necessarily have to write too much for that part. It just basically tells us what it is. So that should be good enough. Okay, so we finished question number 30. It's as simple as that. We just do two calculations. One, we're going to take 2.58 times 16.9 over radical 110. you get 4.16. And after that, we take the x bar minus the something that we just computed, and you take the x bar, we add something that we computed, and we finish that. Okay, so that is the question number 30. This is the part A, right? Chapter A, part 1. And now we're gonna do chapter A, part 2. Pick a question with the S. So now I picked question number 42. So let's do question number 43. Is easier. Let's see what's going on. The same thing. I can definitely see that the question gives us the S. So we're gonna do the T for sure, 100%. So now this is 43. And let me just point it out, put down the questions right there. Okay, so I make it a little bigger for us to see. And now we're going to check that. The question gives us the X bar equal to 21 hours, right? And also the question gives us the S equal to 3.5 hours. And also the question gives us the confidence interval, that'll be 99%. And we need one more thing. We need the sample. So the N equal to 16. This is also a thing that we need to put them down. So this is the N. And so just in case I forgot it. And this is the X bar equal to 21. Right? And N equal to 16. And we also have S equal to 3.5. N equal to 3.5. And we also have 99% confidence interval. Let me just put them down real quick for that part. So this is 3.5. And the CI equal to 0.99. Remember that when a question gives us 99%, then we have to convert to 0.99 for the S, for the T. So again, whenever the question gives it this guy, when we have you go to the T score. So, and now we're gonna do the error bout. So the E that we have is equal to T times S over radical N. So in this case, so we can literally check the T score. So we forgot to do the confidence interval. So the degree of freedom that we have equal to 15. So we need to put them down. So when it comes to the S, there will be a step that we have to do is to compute the degree of freedom. So there'll be N minus 1 equal to 15, right? And then we're going to utilize this part to read the chart. So the questions gives us 99%, and with 15 degree of freedom. So we go to 15 and 99%. So we're going to get 2.947, right? So we're going to go to 15 and 0.99, you got 2.947. Okay, and so again, that we have to do the 15 and 0.89, so we get 2.9.7. So let me just draw a picture for that real quick. You can literally check if the answer. So we have enough space for that part. So we're going to go to 15, and this guy we're going to go to 0.99. So we can see that it is 2.947. Okay, so that's pretty obvious that I can check them. Again, just want to make sure that we don't make mistakes on it. And after that, we're going to utilize this value. So 2.947. We multiply by S, which is 3.5. And then we divide it by radical N. Radical N equal to 16. Yeah. No, yeah, so with the degree of freedom that we always have to subtract from 1. Yeah, but for the Z, we don't do degree of freedom. We just read the table 3B. It's simple. It's simple. It's simple. And the t that we need to take n minus 1 so that we can have 15. And but after we subtract from 1, we don't put that radical 15 there. There's always some situations, and for some semesters that people usually put 3.5 on the top and divide by radical 15. No, we only use this guy to read the chart. That's it, right? We're not going to use this to compute the math. So making sure that we only use that here and finish. They finish a job and leave me alone, right? And so I make sure that we're not gonna do it. And after that, we divide with radical n will be the n that we just have from the questions. We have 16 tablets, right? So we have to divide by radical 16. So so the answer that we can have will be 2. So we're going to take 2.947 times 3.5 and over radical 16, we hit the second, and then the square root and 6. If you know radical 16 is 4, that's simply, and just divide it by 4. We don't know it, just take the square root and divide it by 16. And so the answer for that is 2.57 or 2.58, okay? So we're going to get 2.57 for the error bell. And after we get this guy, and then we're pretty much done. So we're going to take x bar minus the error minus the e, and then x bar add the e, okay? So remember that we do not always do like n minus 1. Remember that we only do n minus 1 when we have the s. You have to deal with the t. When it comes to the z, I don't do degree of freedom, right? I just literally go to the table number 3b right after I got a confidence interval to figure out the z score. So so after that, we go to compute the rest of it. So this is the range for the mean, the population mean for that part. Yeah. So again, this is the range for the mean. This is not the true value. This is just the range. We don't know what the average of all the population is, but I can basically tell you that the mean should be between this and that at 99% confidence. So so the x bar that we have is 21, and minus the error value is 2.57. So let me just write them down using the number. It's easier to read. So I'm going to take 21 minus 2.57, and we take 21 plus 2.57, and that's pretty much the things. 2.57 and 21 plus 2.57, 18.43 and 23.57. And so the answer for that is 18.43 and 25, no, I'm sorry, 23.57. Okay, so we can conclude that, hey, I'm 99% confident. So because, I mean, there's still 1% chance that we make a mistake, that the mean basically fall off this bow, but I'm 99% confident that out of the 16 tablet, I can conclude that the battery life for the tablet, for all tablets, should be between 18 hours to 23 hours, okay? So this is what we have to do. So some people conclude that, is that always true? The answer is not always. Sometimes we have to do repetition. We have to simulate that instead of doing 16 tablets for only one time. So in order to make sure that this bow is correct, so we have to repeat them. Okay, so we have to do it. We collect 16 tablet once, twice, maybe 100 times, and then we compute like 100 confidence interval to see whether or not it's going to give us the bow between 18 hours and to 23.57 hours. To make sure that this is the true mean is lying within this range. It is not easy, right? So if we only do it one, this guy might not be valid, but this is all we can do for this chapters. Okay. So when we come back on chapter A part 3, then we're gonna deal with the how we're gonna basically control the error bell and the sample size. Sometimes you don't want to collect 16 tablets. That's too much, right? And sometimes you feel like it seems to be easy, right, to collect 16 tablets. So I want to collect more. When what happening is when they collect more tablets, so when you have the n is big, the error bar is small, right? So when the error bar is small, the estimation is better. Anyhow, and this is all we have for chapter 8.2. I mean, chapter 8 part 2. Any questions so far? Any questions?
Somebody asked a question in the on the chat, like on the text.
Yeah.
Somebody asked, they said, do we always have to subtract 1 from n?
Yeah, so this is, I just answer. Whenever the questions gives us the t, right, the s, a little s right there, the question gives us sample standard deviation, a little s, then we definitely have to do the degree of freedom n-1 when you read the chart. So let's say the question gives us 16, then we have to go to 15. If the question gives us 30, then we have to go to 29, and so on and so forth. However, when you do the calculation for the error, then we have to use 16, right, for the radical n. That's pretty much it for the t. But when it comes to the z, that's simpler. So you can see this question right there, that we don't necessarily do n-1, whatever it is. Just go straight to table 3b to get the value of the confidence, okay, of the score. So that's pretty much for chapter B part 2. There will be a quiz, so that will be the last quiz that we take. But I mean, I'm gonna give up. I'm gonna give out some makeup quiz later on. But so the quiz number 5 again. We're gonna go to the assessment. There will be a quiz right after we finish chapter 8. Okay, so the quiz should be taken next Tuesday. Usually after the review. I would say I would ask people to take the quiz on Thursday and see if they want to take it. But usually, this is a very important chapter 8, part 2, and for the T, because it's harder. We have to look for n-1 degree of freedom, and after that, compute the errors and do the confidence interval. So let me check what question is this. Question number 43. And so let me just rewrite this. This is 43, and we've finished that. Okay, so no more concerns? Any other concern that we have?
No concerns.
No concern. Okay, so again, there will be a small quiz. Pretty much the same thing. You click on the file on Thursday that based upon chapter 8 part 2. Remember, right after we finish chapter 8, then we're going to have a review and then the second exam. So since we do not have a lot of time left, so after the review we have the exam, and then I'm going to spend 2 lectures on chapter 9 and 2 lectures for the final exam. I mean, to review for final exam. There will be 2 practice final exam. Just do them. If you have any questions, let me know. I will post solution on it as well. Okay, just the answers. Okay, so that's pretty much it, and I hope you guys going to enjoy your day, stay safe, and stay healthy, and I will see you guys on Thursday. Take care.
Okay, bye.
Bye.
Bye.